And please, ladies and gentlemen, welcome Raul Poblana. Thank you so much.
Hello, everybody. Good afternoon. My name is Raul Poblana. I'll be speaking in English, so I will try to go a little bit slower, if that's okay. We're trying to do a mobility on demand solution here as a part of the Herico project, but it's based on research that we've been doing at the MIT Media Lab for about 7 years now, trying to develop a one-way shared use system for vehicles. And so here you actually see on the cover slide, which you might have seen yesterday, I'm not sure, I wasn't around for that presentation, the idea for the 2-passenger fully electric city car, which is going to be implemented as a production vehicle within the Herico project. One of the things I wanted to illustrate was that there is a book called Reinventing the Automobile, which is available by our former professor who recently passed away, William Mitchell, who was the guiding light for this project and this vision. Overall, I'm going to give you a little bit of a summary and a background. We're looking at ways to be able to deal with urban transportation. The majority of the world's population is moving into urban environments. More than 50% of the world's population now lives in cities, and about 90% of the population growth will be in cities as well, and that will account for about 80% of the world's wealth. So one of the other interesting things, too, is that 60% of the energy that's being used inside of the cities is for transportation and for building infrastructure, and that 40% of the gasoline that's being used inside of cities is actually for looking for parking spaces. So what we're looking to do is we're looking to be able to build off of what ideas we might have or concepts of mobility we might have, including private transportation, public transportations, and the last mile solution. The private transportation scenario has a couple of problems because it has congestion, pollution, parking scenarios, and liability issues for the owner of the vehicle. Public transportation is great, but it doesn't provide the full solution to the first and last mile problem. So what we're looking to do is to create a shared use system which allows the user to be able to access a number of multimodal mobility solutions where you're part of a shared use one-way program, similar to what you might find for one of these bicycle programs in Barcelona, in Berlin, or also in Paris. What we're looking to do is we're looking to be able to create a fleet of electric vehicles that would be able to give the user a chance to be able to pick up one kind of mode of mobility. Maybe it's a power assist bicycle or an electric scooter from any of these locations throughout the city, drive it to another load or drop-off location, or possibly even just leave it where they need to be parked and tag it within a smart mobility network, mobile device network. Or also, and then possibly pick up another type of vehicle like the city car once you maybe did some grocery shopping and you needed to be able to bring some payload back with you. We also want to be able to tie the vehicles into the city infrastructure. So it's very important that there's a seamless connection between the charging infrastructure and the infrastructure or the power grid inside of the cities. We also want to be able to use some of the existing transformational capacity that's available inside of the buildings to be able to ease the transition into an electric vehicle economy. So there is a need to be able to create a smart interaction between, let me see if I can get this going, a seamless interaction and smart grid technology that will allow for more efficient power transfer and more efficient use of electric vehicles in the city. Looks like I'm going to have some problems here with my videos. So I'll just keep on moving. This next slide basically is showing you a little bit of the idea of what the city car would be able to do. So it's a 2-passenger fully electric vehicle which folds to be able to save space, so it adapts to the city. It has omnidirectional motion because it has 4 independent wheel robots with integrated drive, suspension, steering mechanisms inside of them. So you're allowed to be able to do more choreographed motion throughout the city. which includes an O-turn, basically a scenario of a U-turn, but the vehicle would be able to rotate on its own footprint, as well as do 90-degree parallel parking into different parking spots. We're also looking at ways to be able to get rid of the charging plug by using wireless power transfer or inductive power transfer, which you see in the bottom left-hand corner of the screen. And this basically is a means for us to be able to do both rapid charging and level 2 charging being on the order of about 2 hours or so for a shared use system, but also possibly it gives the opportunity in the future to be able to charge the vehicle while it's driving on the road. And some of the scenarios that you see for inductive charging actually are in environments like factories where robots are able to follow a path or actually move from one inductive charge rail to another, or one inductive charge pad to another. And we can start to create, with this electronic vehicle that we're building, an autonomous solution which allows you to be able to go from one charge node to another by doing some motion planning. On the other side, the right side of the screen, you start to see that the vehicle is a completely drive-by-wire solution. So the vehicle does not necessarily need to have a steering wheel, but we will be providing the opportunity for a steering wheel because people are very familiar with that interface, the driver interface. But we won't have any mechanical connections between the driver interface and the actual drivetrain of the vehicle. So we're looking to be able to create more of an electronic car versus an electric car with a lot of robotic capabilities or mechatronic capabilities, and as well as a number of sensing technologies to be able to do autonomous parking and also autonomous wayfinding. And unfortunately, it looks like all my videos are not going to play today. So I might be able to, let me see if I can just dig them up out of my folder here, so that way we have something to look at. Apologies again. I'm a Mac user, so the Mac Windows scenario sometimes comes and gets me in the end. But I have this video which should be able to play, which shows you our robo-scooter technology, which is a two-passenger one-passenger, two-wheel drive electric scooter that was one of the early vehicles that we were trying to explore the ideas of adaptable vehicles for the city, which would save space, particularly because this vehicle was designed for a Taiwan deployment where parking is at a premium and lots of users actually park on sidewalks.
The robo-scooter
and we'll listen for a second to Bill Mitchell, our advisor who wrote the Reinventing the Automobile book.
It's a folding electric motor scooter that provides convenient, inexpensive urban mobility. It's clean, it's green, it's silent. It reduces urban congestion. It folds up to occupy very little space when it parks.
I'm going to demonstrate how to fold the robo-scooter. We have to first switch the control mode from the all-wheel drive mode to a rear-wheel drive mode. And then once you switch the button, you have to push the seat down. There's another button in the front handlebar. If you press the button, you will release the front handlebar like this. After this, you will lift up the body a little bit and press the throttle, and there will be power provided to the rear wheel, which helps the whole scooter to fold in.
The other aspect of innovation has been looking at the ownership model. How is this bike being used by people? So this bike can be used privately, sold privately, so you can own it and keep it. The other model is to look at sharing of the bike. So by sharing, someone can take the bike, bring it somewhere else, and then leave it for others to use. So we have much better utilization of the bike, and that really helps to reduce congestion in the city.
We believe that it will.
Sorry, so I'm going to be transferring back and forth between this presentation and videos, so my apologies and thank you for your patience. Let me see if I can get this back up. The next scenario that we were looking at was an electric assist bicycle, and this actually used another robot wheel technology where the batteries, the control electronics, and the drive motor were all integrated into the hub of the wheel. So this is the